All right, section 3.9 with the very in-depth title, Theorems. So a couple of theorems. First of all, the perpendicular bisector theorem, which says that if a point is on the perpendicular bisector of a segment, then it is equidistant, meaning the same distance, from the endpoints of the segment. So if you're looking at our diagram over here off to the right, CP is our perpendicular bisector because it's splitting the segment into two congruent segments, and we have that 90-degree angle. So what the perpendicular bisector theorem says, that point C here is the same distance from A as it is from B. So we could say that AC is the same thing as BC. And we have the converse of that, which means we can work it in the opposite direction. So if we have a point, I'm looking at this diagram over here, if we have a point D that is the same distance from the endpoints of a segment, which it is because we're marking it right here, then it is on the perpendicular bisector. So that means that CP would be the perpendicular bisector. So it works forward and backwards. We also have the angle bisector theorem, which says that if a point is on the angle bisector, in this example that would be point D, it's on the angle bisector, then it is equidistant from the two sides. So that means that BD and CD would be the same. It would be congruent. That works in reverse as well. If we have a point that is equidistant from the two sides, so if we already know that BD and CD are congruent, then D is on the angle bisector. And even further, we could say AD is the angle bisector. So what can we conclude from these diagrams, if anything? Well, we have what looks to be an angle bisector here in BD, which means that AC and DC are congruent. Or AD and CD are congruent. What can we conclude here from number 2? It might be tempting to say that QS, this ray here, is an angle bisector, but the key here is that these would have to be perpendicular distances, and because we don't have those boxes there to signify that, we cannot say anything. So we're just going to say nothing. All right. Letter B, we can say with extreme confidence that BD, so this ray here, is an angle bisector. I'm just going to do this. And you can even say it bisects angle, let's go CBA. And how do I know that? Because of the converse of the angle bisector theorem. We have these two lines, which are equidistant and perpendicular. They are congruent and perpendicular, which means that D is on the angle bisector, which means that BD is the angle bisector. Down here, now we're just using numbers instead of the markings, but we could say with confidence that the measure of angle GFJ also equals 42. So this angle and this angle would be congruent because, again, that perpendicular distances up here are congruent because they're both 7. So J is the angle bisector, which means both those sides are the same. Very similarly, here we could say that X equals 15 because we know that we have an angle bisector here because they're both 27 degrees. The perpendicular distances, which we have here, are the exact same. So X equals 15. That's it.